Good morning and welcome to Chapter 2. Chapter 2 is about lines. We're going to focus more. Chapter 1 I know was scattered in the topics. Chapter 2 is about lines, linear equations, and inequalities, linear functions. A lot of it's going to be stuff that you actually really remember from Algebra 1 most likely. But towards the end we are going to get into linear absolute value functions, which is something that people tend to struggle with a little bit, and maybe even some new stuff with curve fitting, and we'll see how to use a calculator to help us out with that. But we are going to start out with solving linear equations and inequalities. If there's one thing you remember from Algebra 1, this is probably it, because it's something that you do all the time in Algebra 1. So let's take a look at these. We do have some learning targets today. The first one, I can solve linear equations using a variety of methods. And the second one, I can solve linear inequalities, which makes sense coming from a section titled Solving Linear Equations and Inequalities. So first, let's look at equations. There are several ways of doing a lot of these equations, but generally speaking, you want to go from the outside in. Equations are like onions in that they both make people cry. No, wait, no. Equations are like onions because they both have layers. You want to peel the layers off from the outside, working your way in. And so, example, we have 8 times x minus 5 equals 72. We can divide both sides by 8 because that's the outside layer. And when we do that, that just cancels out the 8 here, and we get x minus 5 equals 72 divided by 8 is 9. And then add 5 to both sides. We get x equals 14. Now, as I mentioned, that's not the only way to do this problem. What's another first step we could have taken right here? We could have distributed that 8. Which way is going to be better? Well, they're both kind of the same. Distributing will always work nicely. The numbers get a little bit bigger, but that's okay. Dividing first, hey, the 72 divided by 8 is 9. If this was 70 divided by 8, which doesn't come out to be a nice number, distributing first might be the better option. That way, you'll probably end up with a not nice number at the end, but you won't have to deal with it for a few steps in the problem. So, anyway, we could distribute first. We get 8x minus 40 equals 72. Add 40. Get 8x equals 112. And then divide by 8. We get x equals 14. So either way, we do get to the same place. It's just there are a few different ways of going about some of these problems, and that's okay. We have another one. This one has variables on both sides. Why don't you take a few seconds, try this one, see what you can do. You can pause the video if you need to. All right, did you try it? All right, well, let's look at this. The first thing we need to do is we need to move the variables to the same side of the equal sign. Personally, I try to make it so the variable is positive. For no reason other than in the end, the last step when we divide, we'll be dividing by a positive number, which is just one less thing to mess up on. And so to make it positive, I'm going to add the 4c to both sides. Move the variables all to this side means we need to move the rest of everything else to the other side, to the left. So to get rid of the plus 20, minus 20, minus 20. And these are all properties of equality, by the way. It's addition property of equality, subtraction property of equality, division property of equality. There's multiplication property of equality too. All those say is that you can do pretty much whatever you want to an equation as long as you do the same thing to both sides. So we have 5 minus 20 will be negative 15. Then that goes away. The 20s go away. C plus 4c is 5c. And divide by 5. We get c equals negative 3. Alright, pretty easy. Remember when I said that this is probably stuff you remember? Alright, try a different one. Now in this case, if we tried to divide first, that wouldn't really do us much good. So I would take the distribution as your first step here. Alright, go ahead and try this. Again, pause the video if you need to, and then start it again when you're ready. Alright, are you ready? So, first step, distribute. When we distribute, we have to distribute that whole -2, because the negative is part of that 2. And so we get x equals -2x plus 6. And then we can move the x's to the other side by adding 2x to get 3x equals 6, and divide by 3 to get x equals 2. What did you do? Couple things I wanted to point out here. When we get our answers are like x equals 14, c equals -3, x equals 2. The answers are not 14, -3, and 2. Notice there's an equal sign in the beginning. There has to be an equal sign in your answer. And in my work, and this happens when I'm on paper and on the board too, notice my equal sign goes straight down in a line. It doesn't move over and do all sorts of crazy stuff. That will help when these problems get harder. Keeping your equal sign in the same place in a line makes things easier. It makes things work better, and it will save you from making horrible, horrible mistakes later on. Right now, yeah, it's probably not that big of a deal, but it's a good habit to get into. Also notice my work. My work is right with the problem. I have this problem. It's right here. You don't actually, like, I don't make you show like the divided by 8, the plus 5. You could just put the stuff that's in the black writing down, and I know where you're going with that. But the work is here. I don't have a list of answers with the work scattered over here. I don't have the work on a separate piece of paper than the problem and the answers. The work is with the problem and the answer. That is part of it. Personally, I would rather see your work than the answer. If you can get down to x minus 5 equals 9, yeah, you can probably get to x equals 14. The work needs to be with the problem. If I have to look for your work and search for it, you did not show it. So, I'm sure I'm going to have to remind some people of that too at some point. Anyway, equal signs go straight down the paper. The work is right with it. And let's look at another one. So go ahead and try this one. We have a couple extra variables here. It's a little bit bigger. Ooh. -4t plus 1 equals 3t plus 1 minus 7t. So go ahead and give this one a shot and see what happens. Did you do it? No, try it. Actually give it a shot. Alright, well, if you haven't listened the first 2 times, you're missing out. The whole purpose is you do it, and then you can see. Anyway, so this one, we have this -4t over here. Let's add it to the other side. So add 4t, add 4t, and so we have -4t plus 4t goes away, so we'll have 1 equals 3t plus 4t is 7t minus 7t is also 0, so we end up with 1 equals 1. Well, that's weird, because in the other problems, we still have our variable. X equals something, X equals C equals something, X equals something. Here, the t's just disappear. Well, we have something that we can do when variables disappear. And the nice thing is it's always the same. Sometimes the notation changes just a little bit, but for the most part, it is the same idea. When variables disappear, which is a fantastic song name, by the way, it's one of the songs from my band. When variables disappear, one of 2 things can happen. What's left is either true or false. If it's true, it's called an identity, which means everything works. You can plug any number you want in there, it's going to work. Well, what can we call it if we can plug any number in and everything works? all real numbers. So when the variables disappear and what's left is true, it's all real numbers. When the variables disappear and what's left is false, it's called a contradiction, which means nothing works. If nothing works, that means we have the empty set. That's not 0. That's not x equals 0. It's not even x equals the empty set. It's just the empty set, which could also be called no solution. So looking back at our problem, is what's left true or false? 1 equals 1. True or false? True. What would be a false statement? 1 equals anything that's not 1. Like 1 equals 2. I know some people, when they do this, they also probably went -1, -1. You get 0 equals 0. Also a true statement. So it doesn't matter if you did an extra step there. It'll still either be true or false. It's not going to change it. And so 1 equals 1. That is true, which means all real numbers. The true is part of the work. All real numbers would be the answer. Sometimes the directions will have you identify whether it's an identity or a contradiction. If it tells you to do that, I would do that. Let's look at another one. So we have 2 times 3x plus 1 equals 3 times 2x plus 1. First step here would be distributing. Dividing is just going to cause issues. So let's distribute. The 2 times 3x is 6x plus 2. 3 times 2x is 6x plus 3. And then we can subtract 6x from both sides to get 2 equals 3. So our variables disappeared. Is what's left true or false? 2 equals 3. Well, 2 does not actually equal 3, so that would be false, which means it's no solution. It's the empty set. You could write out no solution if brevity isn't really your thing, but it is mine, so I like the symbol. So that would be solving linear equations. Most of the time, we're going to get an answer. X equals something, C equals something, whatever our variable is equals something. But there are times when you'll end up with an identity or contradiction where you solve it the exact same way, but your variables disappear, and then you have to know what to do with that. Solving inequalities are actually just like solving equations with 2 differences. The first one is that you have to remember to flip the sign when multiplying or dividing by a negative number. Less than becomes greater than becomes less than. If it's an or equal to, it stays an or equal to. That won't change. It's just the way it's pointing changes. So that's the first one. The second one is we need to graph our answer, graph the solution, and that's just on a number line. So if we start out with a problem, 62 minus 18x is less than 20. Solve it the same way. You can subtract 62 from both sides. To get negative 18x is less than negative 42. Divide by negative 18x, or divide by negative 18. Being that we're dividing by a negative means we have to flip that sign. And we get x is greater than 7/3. Graph it on a number line. So we get our number line. We're going to put a dot at 7/3. It's a greater than, it's not an or equal to, so it's an open dot. It's one of the ones that's not filled in. And we want when it's bigger than 7/3. One idea is to plug in a number. We could plug in 5. Is 5 bigger than 7/3? Yes. Is 0 bigger than 7/3? No. We shade the side that it works with an arrow. And notice my arrow is on the number line. It does not come up and go over. I know there's some teacher that teaches it that way. It is technically not particularly wrong, but I have seen that end up get you in trouble almost 100% of the time when we get into harder inequalities. Do it on the number line. So if x is greater than 7/3, it's graphed. So open circle, then goes over. And so we have open circles and closed circles. The open circles are for less than or greater than. Closed circles Oh, and parentheses. Closed circles are for the or equal to's, which come with the brackets. And that would be it. That would be the rest of inequalities. So they're just like equations, except that you have to graph them, and you have to make sure you flip the sign if you multiply or divide by a negative. So I'll see you next time for proportions. Until then, have fun with the work.